Section 4.4, homework problem number 5, 6, and 7. So in number 5, we're counting the total number of seats, which I talked about in class already. But pay attention to the instruction. So we want you to explain how to use this situation to illustrate the distributive property. So we want you to show two different ways to count the total number of seats, and these two different ways are equal to each other, and it demonstrates the distributive property. Okay, so let's see. I use the goodie bags example, and which is very similar to the cars. So each goodie bag has 2 red pencils and 1 green pencil. And so let me draw a picture. Let's say we have 2 red pencils. So you will be able to see 2 red pencils. The first goodie bag, we have first, second, third, and the fourth. And then we have 1 green. I'm going to use 1 green. Okay, so together that's a goodie bag, goodie bag, goodie bag, and a goodie bag, and a goodie bag. So notice that when we count the total number of pencils, we could do count how many in each goodie bag. So that's 2 red plus 1 green. That's a total of 3. And then we do 5 times 3. That's a total of 15. That's one way to count the total number of pencils. But we could also do, notice when I was drawing the pencils, because I didn't want to switch between the 2 different colors, I actually drew all the red pencils first. And notice that's 5 twos, because there are 5 groups. Each group has 2 red pencils. So that's 5 twos. That's a total of 10 pencils. And then I drew all the green ones. That's 5 ones. So 5 2 red pencils, 5 1 green pencil together. That's a total of 15. And notice that these two are equal to each other. So I probably should add a sentence that saying these two are equal to each other. So that would demonstrate the distributive property here. So I'm just going to do a copy and a paste. So whether we count the red and, so I'm going to say, so they are equal to each other. So I guess I can copy this one first, because that's what we usually do when we use the distributive property. So we have, we distribute a 5 to 2 to get 5 times 2, and 5 to 1 to get 5 times 1, and add them together. So these two different ways of counting the total number of pencils, they must be equal to each other, because both of them tell us how many pencils we have in the goodie bags. And then that should, when we set them equal to each other, that's exactly the distributive property. Now, in number 6, we want to draw arrays to demonstrate the distributive property. So what I'm doing here is, okay, so we can see that part A, I use different numbers. 3 plus 2 times 6 equals 3 times 6 and plus 2 times 6. It's like distributing 6 to everything in the parentheses. So when I draw this, I'm going to use the numbers in the parentheses as my rows. So I draw 3 rows, and then two rows. For the top 3 rows, I didn't color them, but I have just white colors, and then 2 yellow colors. Now 6 columns. 6 means columns. So I have 6 columns here. 1, 2, 3, 4, 5, 6. And again, when we counted the total number of boxes here, we could add a total number of 5 rows times 6 columns, or we could count how many white boxes we have. So that's 3 rows and 6 columns. That gives us 3 times 6. And then we're going to count the total number of yellow ones. So we can count the total number of yellow ones, which is 2 rows and 6 columns, 2 times 6. So either way, either add the rows together and times the column, or separate them as 3 rows and 2 rows, and the answer should be the same. Okay, next one, they moved 5 and put it in front of it, but it's the same thing. We can distribute it. So we will distribute 5 to 2 and 5 to 1. So I have 5 rows, 1, 2, 3, 4, 5 rows. And for the columns, I separate them into 2 white columns, 1 yellow column. So again, you could add all the columns together to get 2 plus 1, which gives us 3, and then do 5 times 3, so 5 times the total number of columns. Or you could do, you can do 5 columns of 5 rows and 2 white columns, and then you do find out 5 rows and 1 yellow column and add them together. Now finally, the subtraction also works for distribution. So we're going to distribute 5 to 7 and 5 to 2, and it's kind of similar though. So first you draw 7 columns. Notice 7 rows, 1, 2, 3, 4, 5, 6, 7. And because we're just using the drawing instead of animation, so we're supposed to cut away 2 rows. Minus means take away 2 rows, but we cannot really cut it away here, so you're just gonna highlight them, say the yellow ones will be cut away, so cut away or take away. And notice how many white, so the white boxes are left, and how many white blocks are left. And notice that we could count the total number of how many we started with, which is 7 times 5, 1, 2, 3, 4, 5 columns. So that's the total number we started with. But then because we took away the yellow ones, how many did we take away? It's 2 times 5, 2 rows and 5 columns. So these yellow ones are taken away. So what's left will be the white ones. And so that also works. And of course, you could go ahead and just take away 2 rows. So you're just going to do 5 rows times 5 columns. That gives us the total number of white cells directly. But you could do the total number of white and yellow together, and take away the yellow ones. That will give us the white ones. So that also demonstrates the distributive property over subtraction also works. So for number 7, explain how to use the distributive property to make 31 times 25 easy. So notice that we also have the number 25 because 25 times 4 is 100. It's an easy calculation. And if you remember in previous section, we did a homework question example like 12 times 25. In that example, we did not use the distributive property. We used the associative property because we can write 12 as 3 times 4. And then we can move the parentheses from 3 times 4 to 4 times 25. And that is turned into 100. So we got 300. So notice here we use all the operations we have are multiplication. So this property is called associative property because we did not move the numbers and we did not distribute any numbers. It's just associate 4 with 3 or associate 4 with 25. So it's called associative property. But in this example, we're going to do something different. We are going to break down the number, either 31, 41, as 40 plus 1. And notice this is a different operation. So this is different from what we did before. So previously we used multiplication. So it's all multiplication. But right here we have a different operation, which is addition. And so notice that when you have addition multiplication, we got to use the distributive property, not associative property anymore. So we're going to distribute 25 to 40 and 25 to 1. So 40 times 25 gives us 1,000. And because we can break down 40 as 10 times 4 times 25, and this is associative property here. And 4 times 25 is 100. Whenever we multiply a number by 10, we just add another 0. So this part right here is something we did before. So I didn't give a detailed solution, but if you didn't know how to get that, that's what we did. Okay, so first we use the distributive property right here in this step. And we could do this in our mind and write an equation. So I did write the equations here. draw a rough picture of array. So we don't have to draw the detail, just a rough picture. So we could draw a box. So this is similar to what we did here. So we could draw a box, but we don't have to draw all the rows and columns because the numbers are big. So we don't really want to draw 40 columns and 25 rows. So you could just draw a big box. And okay, so we have 41. I did 41 columns, but you could do 41 rows if you want. It doesn't matter. So I have 25 here, 40 here, up there. 40, break 40 as 40 plus 1. So all you have to do is divide the columns into a 40 column, a big box, and 1 column. And so when we calculate the total number in here, so we could do 25 rows times 40 columns, although I didn't draw the rows and the columns because it's just a rough picture. So that's 40 rows and 25 columns. 25 rows and 40 columns. And then we are going to do the other part, which is 1 times 25. So each of the yellow part corresponds to 40 times 25, and the pink part corresponds to 1 times 25. When we add it together, that is exactly 25 times 41.